All right, so let's go ahead and give this a whirl here. Um, One of the things I've tried to do with this particular course is find ways to get you some assistance out of class. So on a weekly basis, and this week being a few more problems as it's mainly pre-calculus that we're doing this first homework assignment. You may see as many as 15 or 20 homework problems. In the future, the number of problems may go down a little bit for each of the sections, but my goal is to do a subset of those homework problems for you to watch on video, and I'll post these on YouTube. So you'll have to bear with me a little bit. This is my first time doing this. I'm trying to use something called a Wacom tablet to perform the problems that live on some PowerPoint slides. So let's go ahead and get started. Section 1.1, number 15. Graph the function f of x equals the square root of 4 minus x squared and state the domain and range. So first off with this one is that I can see that there's some numbers that I'm concerned about here. Things that I might not want to put into this particular value. So let me, I got to go to slideshow here first. There we go. First of all, I don't want, x can be 0. That's fine. 4 minus 0 is square root of 4. I can do that. For me, working with this, I always want the square root to be a positive number. I don't want to get into the imaginary number set. I actually want this to be a positive number. So I can already tell that the domain is a little bit limited. The domain, this one's a little bit weird because I'm actually going to come up with the domain ahead of time. I don't want to subtract a number greater than 4. So can x be 0? Yeah, x can be 0. Because 4 minus 0 is 0. Can x be 1? Yeah, absolutely. X can be 1 because 4 minus 1 squared is 4 minus 1, which is square root of 3. Can x be 2? Well, this is where we're getting close now. 4 minus 2 squared. Well, 4 minus 2 squared is 4 minus 4, which is 0. Can x be 3? Nah, 4 minus 9 gives me a negative number over here. So my domain right off the bat, I've kind of determined that. Well, take a time out here, though, because this can definitely be 0. I guess one other question is, could it be a negative number? Negative 1 squared is still 1, so 4 minus 1 is still a positive number. And how about a negative 2? A negative 2 squared is still 4, so 4 minus 4. So domain on this particular one actually goes, it goes from negative 2 to positive 2. Again, getting used to this deal here. And because it actually includes those numbers, these are square brackets. If it wasn't allowed to be negative 2, but it was allowed to get really, really close to negative 2, like 1.99999, this would be a parenthesis or a round bracket. But because negative 2 is allowed to be in the set, it's going to be a square bracket. So I'm kind of jumping ahead here, but let's take a look at what this thing looks like. So I'm going to try to graph this thing first and foremost. Let me get my marker here where I can get some good lines, and maybe I'll go from here down to here, and maybe I'll go from here over to here, and put some arrowheads on here. There's an arrowhead, there's an arrowhead, there's an arrowhead, and there's an arrowhead. And I will have, I'm going to call these x and y, but we know we could also call this x and f of x. X is what I plug into the function, and f of x is what I get out. And a lot of times we just call these x and y. So I know I go from negative 2 to positive 2. That's all I'm allowed to have for x, so there's no sense in going too far one way or the other. I'll go negative 1, negative 2, and I'll go to negative 3 just to be safe. And then I'll go 1, 2, and 3 in the positive direction. And I'm trying to think of how high I'll go on this. So the biggest number I'm going to get out is 4 minus 0. Square root of 4 is 2. So I guess I only got to go up to 2. 1 and 2, and maybe 1 and 2. So now if I want to graph this thing, what I'm going to do is I'm actually going to come over here and I'm going to type in x and y. And then these are my two values I'm going to work with. And really all I am allowed to work with is negative 2, negative 1, 0, positive 1, and positive 2. So if I take negative 2 as my first variable, so f of negative 2, everywhere I see x, I plug in negative 2. Negative 2 squared is 4. 4 minus 4 is 0. That's easy enough. And then I'll do negative 1. Negative 1 squared is 1. 4 minus 1 is square root of 3. And then 0. 4, well, 0 squared is 0. 4 minus 0 is 4. Square root of 4 is 2. And then 1 again. 1 squared is 1. 4 minus 1 is the square root of 3. And last but not least is 2. 2 squared is 4. 4 minus 4 is 0. Square root of 0 is 0. So those are my numbers. Square root of 3, I guess I could look real quick. Maybe I can, I'll leave it alone. Square root of 3, I don't have my calculator handy here. I know square root of 2 is 1.414, and square root of 4 is 2, so it's somewhere between 1.414 and 2. Better than that, though, we can real easily, let me just make sure I got my pointer on here. There's my pen. We can real easily say that at negative 2, I'm at 0, right there. Negative 1, I'm at square root of 3. This is a positive square root of 3, so it's greater than 1.414, but it's less than 2. Maybe somewhere, somewhere in here. And then at 0, I'm at 2, which is right there. At 1, I'm here again. And at 2, I'm here again. And so this function actually looks kind of like a circle, or the half of a circle, or a half a moon, and that is going to be my range now. If this was my domain, my domain is really from here to here. How much of the x value was I allowed to use? That was my domain. Okay. My range is how much of the y value was I allowed to use? Well, my range only went from there to there. So if you take a look there, we can see our range now is going to go from, it's going to include y equals 0. It's going to include y equals 2. So these are going to be square brackets, and it's going to go from 0 to 2. And just taking a look here, and that all looks good. So that's our first attempt at utilizing some of these online homework videos, 1.1 number 15. We'll go on to another one here in a minute.